Under decimals, this one is little subheading multiplying and dividing. Let's look at multiplying first because they are a little bit different here. Multiplying. The phrase we use when we add and subtract decimals was to line them up. Please understand when you multiply, don't. You don't have to, please don't. Don't confuse yourself with that. If they line up, it might happen. There's an outside chance, but rarely. In multiplying with decimals, what is the phrase, oh, that pesos? Oh, the good child. Yes, Chase.
Don't line up the decimals.
I just said that. That's not the phrase that pays. I just said that's not what you do, Chase. What do you do when you multiply decimals? I suppose I should give you an example. Let's say I am multiplying 7.2 times 0.34. If I'm multiplying those two decimal numbers, what should automatically go through my mind before I even start? And don't say write them up and down or whatever there. Thank you for that. That's not it. Yes, maybe if you raise your hand higher. Come on.
Line up the numbers.
Nope. Nothing about lining up anything.
Aww.
Not about lining up anything. It is about, wow, I know we did this, counting decimal places. Or count, I should put count decimal places. Which means, by the way, I'm just going to use a gray and pink hue for you guys because that's your colors for today. Right off the bat, 7th grade, if this was my problem, right now, Lauren, I would be thinking in my answer there should be 1, 2, 3 decimal places. In your answer, there should be digits, 3 digits to the right of the decimal. You don't line these up. It's 7.2 times 0.34. You don't worry about the decimal until you get to the very end of the problem. You're just going to multiply 72 times 34. Some of you I know struggle with this, but let's see if I can get it right. 3 times 2 is 6, 21. I do my little boom, 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 boom. I get 2448 for my digits, and then I have to figure out where the decimal goes. Don't worry about the decimal until you get your answer. And if you look at it, you know, is gray not an option on any of these? There it is. That's not going to show up at all. I don't know why you wear that stuff. This has 1 decimal place. This one has 2. That's a total of 3. In my answer, there have to be 3 digits to the right of the decimal. Usually what we say, start here and count back 3 places, and that's where your decimal is going to go. I can't do it, sorry. Black is a shade of gray. So the answer is 2.448. Notice how nowhere do any decimals line up. Nowhere. Anywhere. 0. What would happen if I multiply this? Same digits. Oh, look, they line up. Well, that's just coincidence there. Guess what digits I'm going to get at the end of this problem? Can anybody take a shot in the proverbial dark? Does anybody see what digits I'm going to get back there? The digits are, Caleb.
2, 4, 4, 8.
Yeah, I'm still going to get this. The multiplication's not going to change. 2, 4, 4, 8. But what has changed is how many decimal places I have. How many decimal places do I have? There's 2 there and there's 2 there. That's a total of 4. So where's the decimal going to go? Layton Purdue.
In front of the 2.
In front of the 2. Now let's really throw a monkey wrench into the situation here. I hate to like, oh, this is not going to turn out well. I hate to really mess with your minds here. But what if I gave this to you as a problem? 0.0072 times 0.0034. Well, if I write it up and down, 0.0072, 0.0034, can anybody tell me what the digits are going to be in my answer? I know it's going to be a stretch. Lauren? Yeah, I'm still going to get the 2, the 4, the 4, and the 8. They're still the same things. These zeros aren't going to change anything. The real problem, the real quandary, the real crux of the problem here is how many decimal places do I have to get in that answer? If you have to take off your shoes and use your toes to count, feel free. Joseph?
8.
Yeah, 8. There are 4 here and 4 there. That means, unfortunately, I gotta go 1, 2, 3, 4. That only gets me 4. I have to go 5, 6, 7, 8, and then my little dot right there. That's the answer to this. How about that? Anybody happy with that? If the whole number, it doesn't matter if you have whole numbers either. I mean, if you're multiplying, if you are multiplying 16 times 0.5, 16 times 5 is, where's the decimal going to go, Emma?
After the 8.
Yeah, one place, it's 8. Which makes sense because half of 16 is 8. Everybody good with that?
Mm-hmm.
Any more beating of proverbial dead horses? How big actually in real life is that? Not very. Now, over to multiplication, or division, sorry. Maybe I'll just start it. Can I start a multiplication of division of decimals? When we have division, ladies and gentlemen, there are 2 different cases of division that you're going to run into. One of them is going to look like this, 7.6 divided by 5. And the other one may look like this, 7.6 divided by 0.5. First of all, they're division problems, so there's no way to line up the decimals. Let's write them out. Remember, people get confused with division of decimals because, you've been brought up to think that it's always the smaller number, Brian, into the bigger number, but that's not always the case with decimals because you can take any number into any other number with a decimal. What happens when you have it written out like this? When you do the division actual problem, they switch places. The 5 goes outside of the box. The 7.6 goes inside the box. What is our phrase that pays with decimals and division? Zachary?
The decimal.
Yeah, the decimal, move up the decimal. Move up the decimal. And for those of you that have struggled writing in straight lines, rows, and whatever, this could be an issue. But before you even start the problem, take that, move that decimal straight up, because that's where it's going to go in your answer. 5 doesn't go in, 5 does go into 7, sorry. 1 time, right? Subtract 2. Again, I'd appreciate arrows just because, I'm 50 years old, I still do it. 5 goes into 26, how many times, Caleb?
5.
5 times, which is 25. What happens here? I got this 1 left over. And no, you may never, ever, ever have a remainder when you do decimals. Ever. Emily, what happens? Yeah, you have to keep adding zeros even if it goes on forever until 1 of 2 things happens. There are actually 2 options when you keep adding zeros. Anybody know what they are? Either, Madison,
Until you can go into it evenly.
until it ends evenly, or the other option is that.
Keep it going until you get the same number over and
Yeah,
over.
until it either ends or it repeats. Now, if it doesn't end or it doesn't repeat, then you're in trouble because you'll be doing that problem forever. There are such numbers and they're called irrational. But you shouldn't run into that, at least not here. So I bring down my next 0. 5 does go into 10 2 times, so I can stop. Everybody's pretty happy about that. That's case number 1, when there's no decimal here. But what about this one? I do my division. How is this problem going to be different? I know this will stun and amaze your friends. Clausing, how is this one going to be different? Yeah, and the book throws a little, this is move up the decimal. In this one, you have to do a step before you move up the decimal, and the book goes with the little phrase that says over, up. Which means this. You have to get rid of your decimal in this little guy here we call the divisor. Okay, we don't want a decimal in our divisor. It's okay to have it in our dividend, but not in our divisor. So you move it over. But if you move this guy over, he gets a little jealous and he wants the same action. You know that whole, treat me like everybody else gets treated. So I have to also move that over too. Over, and then up from there. Guess what digits I'm actually going to get?
The same ones.
Same ones, it's just that the decimal is going to end up being in a different place. 5 does go into 7 once. 5 does go into 26 5 times. And you still have to keep adding zeros until it works out 1.52. Chances, by the way, are running out. Things are drawing quickly. Oh, did I do something wrong? Oh,
It's
no.
2.2, not 1.5.
Oh. That's. How about that?
No, it's
Oh, I'm sorry.
15.
Oh. The decimal was wrong.
Yeah.
Watch how I can fix that.
Ooh.
Shake it up, baby, now. Shake it up, baby.
See, I was waiting for the answer to be right.
A couple things to be aware of, ladies and gentlemen. Beware of problems that look like this. Beware of problems like that, mostly because you think you're smart enough, good enough just to go, 5 times 5 is 25, blah, 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 put the answer is 2.5 or whatever it is. If you in fact do this problem out as it should be done, what is 0.5 times 0.5? Yeah, it's got 2 decimal places on it. Or this one, 0.01 to the 3rd power. Take a shot at what that would be. Anybody caring to speculate? A whole bunch of 1s times themselves. Are you guessing? Why would you guess when you could actually do it out? Emma?
Oh, 3.02.
0.02. I'm relatively sure 1 times 1 is always going to give me 1. Chase. 0.03. We're getting better still. No. All right, people, come on, work with me here. Look, let's do this out. What does this mean? 0.01 times 0.01 times 0.01. This times this. 0.01 times 0.01. 1 times 1 is, how many decimal places are in that?
2.
Huh?
4.
I now have to multiply that by 0.01. What is 1 times 1?
1.
How many decimal places are in that?
6.
6. 1, 2, 3, 4, 5, 6. Be very, very careful. Who could read that number for me, by the way? As a decimal? What is that? What is that number read in mathematically? Raise your hand if you really think you know. Maybe I won't call on you. Emily? No idea what that number is set out? Like 0.1 is 1/10. What is that? Liv? No. I don't want it to. You're not going to use points. Like this. Look. This, you say, is 1/10. This is 1/100. This number would be, it is 1 million. Yep. As a fraction, it's 1 over 1 million. Believe it or not. All right, kids, I thought that was relatively unexciting. What do we got? 15 minutes? No, 20 minutes.